video is about the law of sines, which is a way of finding missing angles and sides in non-right triangles. Let's start by reviewing one of the easy cases. So first thing it wants me to do is identify whether it's ASA, SSA, or AAS. So I'm going to draw a picture for that. Draw my triangle. I know that capital A is going to be across from lowercase a, angle and side. It gives me capital B is 25 degrees, so I can fill that right in. Opposite that would be side B, which it tells me is 15. And then angle C, capital C, is 107 degrees. And lowercase c, I don't know. Obviously, this picture is not drawn to scale. That doesn't look like 107 degrees, but that's okay. It doesn't need to be drawn to scale. Now that I have my picture drawn, I can identify the situation. Is it ASA, SSA, or AAS? And because it gives me two angles and one side that's not between them, I know it's an AAS situation. Now I can do part B, which says to calculate the remaining sides and angles. Easiest thing to get is the angle, which here would be 48 degrees. You get that by adding up the two you have and subtracting from 180. Then you're going to use the law of sines, which was on the previous slide, to figure out the other side lengths. I will start by finding side A, which I don't know, but I do know the angle now that goes with it is 48. And I'm going to use the B fraction because I have the side length of B and I have the angle measurement of B. So that fraction is completely filled in. But I cross multiply and solve this for A, and it says round to the nearest 0.01, which is 100th. A is going to equal 26.38. Put a box around that. That's one of the things I'm being asked to find. Then I'm going to set up a similar thing to find side C. I don't know side C, but I do know that the angle for C is 107. And I will again use my B fraction. Since that was the information given to me at the beginning of the problem, I know it's correct. When I cross multiply that and solve for C, C is going to equal 33.94. So that's one of the easier cases. Now let's talk about SSA, which is where it gets complicated. If you have SSA, that's a special case. Either no triangle is possible, one triangle is possible, or two different triangles are possible. How do we know which is which? First thing you want to ask yourself is whether the angle you're given is obtuse or acute, which is what it says at the top of this slide. First ask yourself if the given angle is obtuse or acute. If it's obtuse, we're going to follow the steps on the left, and if it's acute, we're going to follow the steps on the right. And I repeat this information on the next few slides, so you don't need to have it all written down right now. We're going to use them as we do examples. So starting from here, we have one angle, angle A, and we're given two sides, A and B. That's how I know this is an SSA situation. I'm going to draw the picture. I'm going to label angle A as 115. Side A would be 20. Let's say side B is over here, which means this is angle B, and I don't know it. And this is angle C, and that must be side C. Now everything is filled in that I know. And I'm going to go over to my little notes on the side. They're very small. And it says, is the given angle obtuse? Which it is here. So we're going to ask ourselves about step one. Check if the opposite side is larger than the adjacent side. And I mean the opposite side from the given angle. So opposite this 115, I have a 20. And sure enough, that is larger than the adjacent side I'm given, which is 11. If that is the case, only one triangle is possible. And so I'm going to go on and solve this just like I solved the previous example. I don't have to worry about step two because I fall into the step one category here, this triangle. So now I'm ready to solve using the law of sines for the one triangle that's possible. I'm going to use my A fraction because I definitely have both bits of information in it. And then I'm going to find angle B next. It's the only thing I can find next. So I will fill in 11 for the side length, capital B, for the angle that I don't know. When you cross multiply this and solve, you are going to have to use inverse sine to find out what the angle is. And B is going to come out to 29.90 degrees. We're rounding to the nearest 100, even for our angles, just to be consistent. Once I have one of the other angles, I can get the third angle just by subtracting the two that I have from 180. Which means now I can tell that angle C is going to be 35.10 degrees. And with all three angles filled in, it's easy enough for me to get the missing side. I'll go back to my law of sines. Using, again, the A fraction, because they gave me the 20 and the 115 at the beginning, so I know that they are correct. And we'll set that equal to lowercase c, the side I don't know, over 35 point, over the sine, excuse me, of 35.10, which is the angle I figured out. When you cross multiply this to solve, you won't have to use any inverses because we're finding a side length. And the lowercase c, the side length of c, comes out to 12.69. Those are the three things I was asked to find. This was SSA obtuse. Let's look at another SSA obtuse. So in this one, when I draw the triangle, I have the 120 degrees as my angle A. Opposite that is my side A. Let's label side B 25, which means angle B is here. And that means those are the C's. Now when I look at this, I'm going to go to my steps. It says check if the opposite side is larger than the adjacent side. Well, it's not. So because 18 is not larger than 25. So now it says if not, go on to step 2. All right, so now I'm going to go to step 2. It says if the opposite side is shorter than or equal to the adjacent side, no triangle is possible. So in this case, because the 18 cannot be across from the 120, it doesn't make any sense. Since 25 is bigger than 18, and none of the other angles is going to be bigger than 120, we're going to say here that no triangle is possible. And we can stop working on this problem. There's nothing else we can solve for it. It's an impossible case. Now I've changed my notes on the side. I put the acute notes over there because you can see the only angle I'm given in this SSA problem is 51 degrees, which is acute. So I'm going to start by drawing my picture. I have 51 degrees. That's angle A. The side across from it is 3.5. I'll put B over here, which means capital B is here, which means the C's are there and there. And I go to my steps. Step 1, check if the opposite side is larger than the adjacent side. If so, one triangle is possible. So in this case, I have the opposite side being 3.5, and the adjacent side is 5. So I'm checking to see if the opposite is larger than the adjacent. Because this is false, I have to go on to step 2. Step 2 always starts out the same. It tells me first I should calculate the height, which basically means if I was to draw a vertical line through here that makes a 90-degree angle with this, we're trying to find the height of this triangle. We're going to use the formula height equals sine theta, which is our given angle, times the adjacent side that we're given. So in this triangle, the height is going to equal the sine of the only angle we have, which is 51 degrees, multiplied by the side that is adjacent to it, which is our B side. Obviously, the 3.5 is opposite the 51, which means 5 must be the one that's adjacent. And the height here comes out to 3.89. You can also round this to the nearest hundredth, just for comparison's sake. Or to the nearest tenth if you need to. Now we're looking, going back to step 2, to see which one of these three situations it falls into. Is H larger than the opposite side? So let's check that first. Is our H, which is 3.89, larger than the opposite side, which here is 3.5. That's the side opposite our given angle. If this is the case, if 3.89 is larger than 3.5, that means we have another no triangle case. As you see, if H is larger than the opposite side, the triangle is impossible, which, sure enough, this one is. So once we've done all this work, we just determined that the triangle we're trying to draw is not possible. And so we can say that there is no triangle, box around that, because that's the final answer, and move on from this question. And the hardest case of all. This is an acute SSA, because I'm giving you two sides, only one angle, and that angle is acute. So I'm going to start by drawing a picture. I'm putting 40 degrees here. That's angle A, which means across from it is the 13. I'm going to put B right here, which means across from it is capital B. And the C's go there and there. And I'm going to go through my checklist. Step 1. Check if the opposite side is larger than the adjacent side. Is 13 larger than 16? No. So that means I need to move on to step 2. Step 2 starts with calculating the height. In order to calculate the height of this triangle, we're going to do the sine of theta, which here is 40. I might as well fill it in right now. So the sine of 40 times the side that's adjacent to that, which is the 16, because the 13 would be opposite. Sine of 40 times 16, approximately 10.28. That would be the height of this triangle. And now I'm going to check my 3 situations. Does it fall into category 1, 2, or 3? That's what I'm going to check. So we're going to check first, is the height, which is 10.28, larger than the opposite side, which is 13? In this case, it is not, which means we are not looking at the first situation. Let's check the next one. It says, is the height equal to the opposite side? Which in this case, it is not. If it was equal, then we would just continue solving it as the one triangle that is possible, right? We would just jump into law of sines and solve it. But it's not that case either. So we must have the trickiest case of all. Let's check. Is the height, 10.28, lower than the opposite side, which is 13? And is that lower than the adjacent side, which is 16? And if this situation is true, which sure enough it is, that means we have 2 possible triangles. So we are in this situation right here, 2 possible triangles. So I'm going to actually go up and draw a second triangle because I need to actually be filling in 2 different triangles here. The givens remain the same. A and side A are still 40 and 13. Side B is still 16. But I'm going to have different possible answers for capital B, capital C, and lowercase c here. So first thing we're going to get, using the law of sines, I'm going to erase the height here that I found. So we have enough room here to do the law of sines. We're going to start by finding the only other thing we know how to find. So if we're given side A and angle A, the only other thing we can get here is angle B, because we're given that the side B is 16. So I set up my law of sines with my one unknown. You would cross multiply this and determine that using inverse sine, capital B equals 52.59 degrees. This is one possible answer for capital B. I'm going to fill it into my triangle on the left as one possible answer for angle B. The other possible answer for angle B, I'm going to call this one B1. To find the other possible answer for angle B, which is called B2, you're going to do 180 degrees minus the one that you got. It's called finding the supplement of it. Because you know supplementary are 2 angles that add up to 180. Well, if 52.29 is a possibility for B, so is its supplement. So we're going to go ahead and take 180, subtract 52.29 to determine that a second possible answer for B is 127.71 degrees. I will label that in B on my second triangle. So try to make your triangles big enough that you can actually label inside of them, so I can see the 2 possibilities you're coming up with. So obviously the first triangle here has only acute angles, but in the second triangle that's possible, it's possible that angle B would actually be obtuse. Okay, so we've got 2 possible triangles coming out of this. To get our third angle C in both triangles, here and here, you can just subtract the ones you've got from 180. To determine that in the first triangle, C would be 87.71 degrees. And in the second triangle, C would only be 12.29 degrees, which makes sense because the green angle that we found was so big is 127 degrees. There's not that many degrees left over. Now we're almost done. We just have to find side C in each triangle. So to find side C, you're going to have to use the angle C that you just got, which is how you're going to end up with 2 different ones. So we're going to have to solve the law of sines twice here. First fraction I want to use is the A fraction again, since that's the one I was given all along. It said that 13 over the sine of 40 is going to equal C, which I don't know. First, I will do the sine of C from my first triangle, which was 87.71. I'm going to also set up the same thing. I might as well set it up at the same time. Sine of 40, the A values stay the same, but this time I'm going to put C over the sine of the other angle C that we got, which was 12.29. We can call this one C1 in our first equation and this one C2. We are finding two different cost values for side C. When you cross multiply and solve in this situation, C1 is going to equal 20.21 and C2 is going to equal 4.30. Since all of our answers are up here on the triangle for this one, I can actually go ahead and fill these back in. So side C in this triangle is 20.21, and side C in this triangle is only 4.30. That's how you would solve an acute SSA situation that has two triangles.